Hello, in this video I want to take you through a quick example with solving for a resultant using your Pythagorean theorem, so doing some vector math, and then also finding the angle in relation to the x or the eastward line using a counterclockwise method. So please have your notes ready and we'll go through these two examples. For the first example, I'm going to take two vector components. I made an x and y table for each one. The first one has a 20, negative 40, and then the next one is 0 and negative 80. I'm not drawing those individual vectors. I'm drawing their combined vector. So the 20 in the x direction, and then the 120 going down in the y direction. That's the combining of all those vectors, and now I want to solve for the hypotenuse. This is key. We're always drawing new triangles when we're combining these into our x and y tables. The resultant is the name of the hypotenuse of that triangle after you combine all of your x's together and all of your y's together. So please make sure you're using your xy table. It will really help you out in these cases. All right, now to find that resultant, or to solve for the hypotenuse, I'm going to go back to my Pythagorean theorem. We know a squared plus b squared equals c squared. I can then substitute in the 20 squared, we'll call that the a side, and the 120, that's the b side, and that's equal my hypotenuse, in this case, the c squared. Doing a little math here, I'm just going to take the square root of 20 squared plus 120 squared, and get my answer that will be the displacement from the start to the finish after I've combined all the x and y parts together. You might have 2, 3, 4 different vectors that end up being this final triangle. For this one, we have about 121.66. That becomes my resultant, or my hypotenuse, for this combined triangle. All right, let's take a look at how we can find the angle, what that's talking about in terms of counterclockwise. Okay, so to solve for your counterclockwise, I'm going to start with that same combined triangle. We already know the resultant. We figured that out with our Pythagorean theorem, so we're going to just write that down, 121.66. But now I really want to find out an angle. Angles always need points of reference because we're talking about vectors. They are going to point in different directions. Well, an easy angle for us to find here is that one on the top. You can use different angles, but this is probably the easiest because it lines up pretty easy with our coordinate system. If I just do a rough sketch of what this looks like, I have a coordinate system and then there's my resultant vector. Okay, they kind of match up. Now, if I want to tell what direction that's going to go, I can start from my x and go counterclockwise all the way around. That's going to become the angle that I use. All right. I could also go back the other way, clockwise, but if we're using counterclockwise notation, we've got to go counterclockwise all the way around. Now, when I solve for with my trig, I'm going to find theta. Well, theta is that inside angle. It's not the answer that I'm looking for. I need to really add 90 plus 90 plus 90, so I add my 270 plus whatever this missing part is. So I'm going to have to find out what theta is and then do a little subtraction from 90 in order to find out the actual counterclockwise angle. Or another way is you can subtract from your 360. You're going to end up with the same answer. All right, so first to find theta, we got to go back to trig, sine, cosine, tangent. I know the tangent is the opposite over the adjacent. So my opposite side on this drawing is opposite theta, so that's 120, and my adjacent is the 20. So tangent of theta is 120 divided by 20. We're going to solve that, and no, that's about 6. Then I'm going to undo the tangent by taking inverse of tangent, so that theta becomes the inverse of tangent of 6. And that ends up being about 80 degrees, 80 point, let's just say 80.5 degrees. Okay, now remember, that is not my final answer. That's not counterclockwise from my origin. I've got to remember to add in all those other quadrants. That's just the part if I was to measure down. Okay, now to solve for my counterclockwise angle, I'm going to look at my picture, and on the top, I'm going to go counterclockwise from that x line all the way back around, knowing that this is 80.5 degrees. I need to find out what that missing x or missing question mark is. So I'm going to know my theta is 80.5. And I'm really just going to look at my drawing. That's just going to guide my thinking. I know I need to add in the 90 plus the 90 plus the 90. But I also need to add in that missing part. So to find that missing part, I'm going to subtract 90 degrees minus 80.5. That's going to give me what's left in that quadrant, 9.5 degrees, and I'm going to add that onto the 270. All right, remember it's 270 to that point plus that little extra. So 270 plus my 9.5, 279.5 degrees to be exact, should give me my counterclockwise direction for this particular problem. Please draw your sketches. They really help out when you're solving either the combined triangle of all your xy's or when you're thinking about counterclockwise. Hope this helps. Have a great rest of your day. Thanks.